Hello students. In this lecture, we are going to discuss about locus problems on slopes of tangents and director circle. Here is the theory. I am considering one circle x square plus y square is equal to a square. For this circle, two tangents are drawn from point x1, y1. Now equations of these tangents can be written as y is equal to mx plus or minus a into root of 1 plus m square. Now taking mx to left hand side, it becomes y minus mx is equal to plus or minus a into root of 1 plus m square. Squaring both sides of this equation, it becomes y minus mx the whole square is equal to a square into 1 plus m square. Further, solving left hand side, it becomes y square minus 2mxy plus m square x square is equal to a square plus a square m square. Now in next step, I am taking this a square m square to left hand side, and from these two terms you can have m square common. So first term is x square minus a square into m square. The middle term is minus 2mxy, and third term is y square minus a square. As these tangents are drawn from x1 comma y1, one can replace here x by x1 and y by y1. So it becomes x1 square minus a square into m square minus 2x1 y1 into m plus y1 square minus a square is equal to 0. Now if you observe this equation carefully, you will come to know that this is the equation. This is the quadratic equation in terms of m. Now for the quadratic equation, there are two roots. Here I am assuming those roots as m1 and m2. And those m1 and m2 are slopes of tangents. Then according to the formula of quadratic equation, m1 plus m2 can be written as 2x1 y1 upon x1 square minus a square. And m1 into m2 can be written as y1 square minus a square upon x1 square minus a square. This is the formula for sum of roots in terms of quadratic equation or product of roots for quadratic equation. Now I expect you to remember these formulae for solving the problems in circle which are based on locus of a point from which tangents are drawn to circle. Now how these formulae can be used in problems? So here is one question. Find locus of point from which tangents drawn to circle x square plus y square is equal to a square are perpendicular to each other. Now look at the method. Let m1 and m2 be slopes of tangents drawn from some point x1, y1 to the circle. As tangents are perpendicular, we can write m1 into m2 is minus 1. This is the theory from straight lines. Now, earlier we discussed that m1 plus m2 is 2x1 y1 upon x1 square minus a square, and m1 into m2 is y1 square minus a square upon x1 square minus a square. So, this equation becomes y1 square minus a square upon x1 square minus a square is minus 1. Now, taking denominator to other side, we can write it as y1 square minus a square is minus x1 square plus a square. Shuffling the terms, it becomes x1 square plus y1 square is equal to 2a square, and the required locus is then x square plus y square is equal to 2a square. Now we try to understand this whole concept with the help of one diagram, what locus we exactly found. So this is given circle, say x square plus y square is equal to a square. Now to this circle, from some point here, say two perpendicular tangents are drawn. So this is one point from which perpendicular tangents are drawn. I'm considering one more such point from which two perpendicular tangents are drawn. So one more point we obtain. Further, there are two more points we located from which perpendicular tangents are drawn to the circle. Now in diagram I have shown you 4 points, but you can show many more points from which perpendicular tangents are drawn to the circle. When we join all these points, we get one circle. Now, equation of this circle is called as locus of point from which two perpendicular tangents are drawn to given circle. Now, locus of this point is x square plus y square is equal to 2a square. This is what we obtained. Now, this point say I assumed as x1, y1. Now, from this point, two tangents are drawn. Those tangents have slopes m1 and m2. Then we can write m1 into m2 is -1. And I got the equation of x1, y1 as x1 square plus y1 square is equal to 2a square. So that equation can be written as x square plus y square is equal to 2a square. Now this equation also represents one circle. And that circle is called as director circle for the given circle. Now basically what is director circle then? So we are going to define now director circle, and it is defined as locus of point from which tangents drawn to given circle are perpendicular to each other. For given circle, what is the equation of director circle? That is what I am going to mention now. For the standard circle x square plus y square is equal to a square, the equation of director circle is x square plus y square is equal to 2a square. For the circle x minus h the whole square plus y minus k the whole square is equal to a square, the equation of director circle is x minus h the whole square plus y minus k the whole square is equal to 2a square. Observe one thing, if you assume that radius here is written as a, then radius here you will observe that it is root 2 times a, and same is the theory here. Radius of the given circle is a, then radius of the director circle is root 2 times a. So this is one more important point one can note for the director circle. Now in this lecture till the time I have discussed two formulae related to slopes of tangents drawn from some point x1, y1 to the standard circle. Further we have discussed this director circle. Now I expect you to remember this theory for a particular circle, how to write the equation of director circle. That is very important. Now we check one question based on this locus theory. So here is the question. The tangents having inclinations alpha and beta from P to circle x square plus y square is equal to a square. If cot alpha plus cot beta is 0, then locus of P is. Now P is some point. From this point tangents are drawn. Tangents have inclinations alpha and beta. Then we have to find the locus of point P. So here I start with the solution. Let M1 and M2 be slopes of tangents. Now M1 is tan alpha and M2 is tan beta. They have given cot alpha plus cot beta is 0. That is what the data given. Cot alpha plus cot beta is 0. Now cot alpha is 1 upon tan alpha. So I can write here 1 upon M1 plus 1 upon M2 is 0. Now in next step, one can write M1 plus M2 upon M1 into M2 is 0. So further this can be written as M1 plus M2 is 0. Now this is very simple to get the required equation as M1 into M2 goes to other side, it simply becomes 0. Now what was the formula of M1 plus M2? So M1 plus M2 is 2x1 y1 upon x1 square minus a square. So I'm writing M1 plus M2 is 2x1 y1 upon x1 square minus a square. Now somebody may ask, sir, what is this x1 y1? So one can say let P is x1 y1. If you want, I just mentioned point P we are considering as x1 y1 from which tangents are drawn. Now here, if you take this x1 square minus a square to right hand side, it simply becomes 2x1 y1 is 0, and in next step you can write x into y is equal to 0. So the locus equation for the point is xy is equal to 0. So our answer is option number 3. This is our answer. X into y is equal to 0. This is the required locus for the point P. Now such type of questions becomes very simple if you remember the formula which we discussed. Those are m1 plus m2 is 2x1 y1 upon x1 square minus a square, and m1 into m2 is y1 square minus a square upon x1 square minus a square. I hope all of you understood this. With this, we stop here. Thank you.